Hello guys, welcome back to my channel Code with Anish. So in the last video, we have seen the technical design of the security system for microservice, and we already developed and tested the authorization application module as seen here. So in today's video, we will develop the next module, which is the user authentication service. So before starting the development, I will explain the logic to be implemented in this user authentication service. Okay, I will explain the logic using a sequential diagram. So before jumping into the sequential diagram, just one thing to remind, as discussed in the last video, this user authentication service needs to authenticate two types of users. One we can say is a local user who sign in with the username and password, and another is a third-party user who already got authenticated from the third-party provider Google and send an access token to our user authentication service to authenticate. So these two users we need to authenticate in our system. So here is the sequential diagram for the user authentication service. So now first we will start with the local user. So local user, we have two different flow. So one is the sign-in flow and another is the login flow, as you can see here. So for sign-in, from the front end, user enters the username and password and click on the sign-in button. So once the sign-in button is clicked, the username and password is sent to the user authentication service. So this yellow color sign-in database, this all corresponds to user authentication service, which we are going to develop. So it will come to the user authentication service. So in the user authentication service, we will check whether the username entered in the request is present in our database. So we will check that, and if it exists, that means the user is already signed in, so we will not allow to sign in again. So we will send an error message back to the front end saying user already exists. But if it does not exist, that means he is a new user to our system. So then in that case, what we do is we store that user into the database, and then we call the authorization application to generate the access token. And once the access token is generated from the authorization application, from our user authentication service, we send back to the front end. So this is the sign-in flow. Once the user is signed in, he will get an access token. Now, next time when the same user comes, so he has to do the login flow. So here is the login flow. So in the login flow, again, the user will have a login button there. So he entered the username and password in the front end and click the login button. And clicking the login button, a request will be sent to the user authentication service with the username and password. Here also we will again check if the user exists in the database. And in this case, since he is doing the login, the user should already exist. So we do the check, and if the user does not exist, that means he cannot log in. So we send back an error message saying that user does not exist. If it exists, that means the user is already registered to our system. So now what we have to do is we have to verify the password. So the password coming from the request and password we got it from the database. We verify that both are same. So if it is not matching, so that means the user has entered a wrong credential. So we will send back an error message to the front end saying that invalid credential. No, if it is matching, that means the password the user entered and password which is already registered in our system for that user is same. So then what we do, we call the authorization application from the user authentication service, and on calling the authorization application, it generates an access token and send back to us. And from user authentication service, we send back the access token to the front end. So this is the sign-in and login flow for the local user who is registering in our system with the username and password. Now coming to the third-party user. means the user who uses Google as Google as the OAuth provider. Now we have to authenticate that user also in our system. So in that case, we already discussed in the previous video, we will receive the access token from the Google to the front end. And the front end in turn will send this access token to our user authentication service. So this is the request flow here. So we get the authentication access token from the front end. On receiving that, we need to verify the token. So to implement that, we use Springboot security and OAuth2 resource server library. So these two libraries comes with Springboot only. So we will use this library to verify that instead of rewriting a custom logic to verify it. So by using this library, the Springboot framework itself can verify that token received from the Google. So how it will do is, it will fetch the JSON web key. So this is also an access token generated from the Google. So obviously Google will provide a JSON web key that we have to configure in this security configuration, so that it use that JSON web key from the Google and validate this token we received. So if the token is not valid, then we will send an error message back to the front end and no more further processing. That means it is an invalid token or an invalid user or an invalid credential. So we just send an invalid access token message back to the front end. No, if the framework, the Springboot security and OAuth2 resource server was able to verify the token and it found that the token is credible, it is valid, then in that case, we will provide the access to our OAuth provider sign-in API or the controller. So the request will come. So till now the request hasn't hit our controller. Before hitting the controller only, this verification will be done by the Spring security. So it will hit the controller, and from the controller we will check whether the user exists in the database. If it exists, if the user exists, we will call the authorization applicant directly, because we don't need to again insert that user into our database. If it does not exist, we will store that detail in the database and then call the authorization application. So in both the cases, if it exists or not exist for the third party user, we finally call the authorization application to generate the access token and send. So this will be a new access token which this user has to use in the front end to call other microservices. The access token received from the Google or the third party is only used till the validation of our security library. So once that verification is done, then that token is of no value to us. So we will generate a new token back to the front end, and that will be used by the user to call other microservice. So that's it about the sequential diagram. Now we will start with the development of what we defined here in the sequential diagram. Let's start with the development of user authentication service. So this is also again a Springboot application, and we use the OAuth2 resource server library to develop this. So we'll click on the new project and we'll give the name as user authentication. User authentication. I will come to the pom.xml. So here also we need to add the parent library, and then we will add the dependencies. Okay, so in this project basically we need the Springboot starter web, the Springboot starter security, and the Springboot starter OAuth2 resource server. So first we will go with this first three library, and as we continue with development, whatever library is needed, we will keep on adding here. resource server. And we also need the build plugin. Here, final name. Give the same name as the artifact ID. Okay, we'll load the Maven changes, and to start with development, this should be ready enough. So first we will develop this sign-in flow. So this is the sign-in controller, and here we need to call the authorization application, and we need to do a database operation. So maybe we will just discuss about an abstraction model using interfaces, so that the service layer which we are going to develop can be reused across all this flow. So basically in all these three flows, we can see we need to end up calling the authorization application to generate the token. Okay, so maybe first we will create a service for that, and we will then implement that service depending upon these three flows. So we create a package here, new package service, and we'll create a new interface named as authorization service. And what we need from this service should be capable of calling this authorization application and generate token. So let's create another package where we define the request and params. So create as package, and you can VO here, and inside that we'll create one more package, maybe we can say authorization. Okay, and here we will now create a new Java class. So we can give the name as authorization params. Parameter of authorization param. Okay, and here we will create a variable, a hash map variable. So basically a map with the string as key and string as value, and we can specify as header param. Okay, now to generate getter and setter, we don't need to write the code for getter and setter. Instead we can use a library, Lompoc library. So we will add the dependency here. Add the Lompoc library here. Here, the authorization param. We can add that at data, annotation from Lompoc. So this in turn will create a getter and setter. Same way, we need a response also. So we need to collect the response from the authorization application which contains an access token. So okay, we will define a response class also here. So we'll create that as a record because it just contains only one variable which is access token. So we create as a record here. So we added the access token variable in this authorization token response. Now we will come here, and we should write a method name. We can write the method name as generate authorization token, or authorization service generate token is enough. We should make it like the generate token. So its parameter should be authorization param, and response should be authorization token response. So this is an abstract method in the interface, and this has to be implemented in all these flows to generate the token, generate the access token. So let's start with the implementation of this thing. So to implement this, just create one more package here, new package, implementation. So we need to call the authorization application for the client ID, which we configured in the previous video in authorization application, which is the API client ID. So when we implementing this, we can give name of the class as API client authorization service. So that will make meaningful. So this API client authorization service, which will implement authorization service, and this is a service, so we will annotate with the service annotation of Spring. So with this name, it will be clear that this authorization service is used to generate the token for the API client ID. So now we have to call this authorization, means we have to implement the calling of this authorization application inside this method. So to call this, we need the URL of this authorization application service. We need to specify the client ID, the client secret. So all this we can define in the application.yaml file. So here we'll create a new file, application.yaml. Okay, so we define a new key called OAuth, and we kept all the parameters inside this main key. So for one is the OAuth URL, which we seen in the previous video. It's hosted in locally in the port 8080. The token URL is the main URL / OAuth2 token. This we yesterday tested in the Postman also, where we generated the token from this URL, and the client ID, which we are using API client ID, and the secret is API23. So as you can see, when we are running locally, already the authorization application is hosted in 8080. So now we cannot host our user authentication service in the same port. So we have to configure a different port like 8081. So that's the configuration value for OAuth. Now we will use this value in our API client authorization service. Okay, so we have defined 3 string variables: OAuth token URL, client ID, and client secret, and we are referring that YAML properties with the value annotation. So these string variables will be injected with the values present in the application.yaml. Next, what we need is a REST template to call the API. So for that, we have to first create a bean of the REST template. Bean and public REST template, give REST template, and return new REST template. Yeah. So we configure the main class. Just now only I noted that we haven't enabled the Springboot application here. So we will enable that Springboot application, and we should call Spring application dot run. And this main class and the auths. Okay, so we created the REST template bean here. So now you come to the service layer and inject that bean here using auto-wire private REST template. Fine, so we got the REST template, we got all the client secret. Now we can write the code to call the authorization application using these variables. Okay, so I have written the code here. So in the code we can see first we are creating a HTTP headers, and the HTTP headers we are setting the content type as application form URL encoder. This we have seen in the previous video while calling the authorization application from the postman. We are selecting as application form URL encoded, and there we are setting the body as grant type is equal to client credential. Similarly, now coming to the basic auth, as we see in the previous video, this also the client ID and client secret was set as a basic auth. So when we set as basic auth, this client ID client secret has to be encoded to base 64, and the encoding is done by concatenating this client ID client secret along with the semicolon. So first the client ID, then a semicolon, then client secret, then we encode this to base 64, and that will be set as the basic auth. Now this line, so what it do is we are iterating the header param. So here we as we seen earlier, we have a map of header params which will contains the header attributes like the user ID, user provider, authorities and all. So that we are mapping completely to the headers. So how it work is headers dot set the key value of the param. The header param will be set as the key in this header, and the value from this header param will be set as the value here. So that we just write in one line instead of iterating through each key value. It's pretty easy to use the for each and set the value. And this I just told before, this is the body of the request where we set the grant type is client credential. And now with this HTTP entity which contains the header and the body, we call the authorization application, which is a post API there. So we call REST template.post for object. This URL which already defined in the application.yaml with the request, which is the HTTP entity, and we are expecting a response as authorization token response, which will be nothing which contain an access token record. Okay, so now we have implemented this part of calling authorization application to generate the access token, which can be used across all these three flows. So next what we have to do is the main part, the authentication part. So this authentication part for sign in, login and the third party user, there are different logic. So this also we use an abstraction. We create an interface first which has to be implemented in the subsequent flows. So we'll create an interface named as authentication service. So this authentication service, what it has to do is it has to authenticate. So this the full process is called authentication. For sign in, the user should not exist in the DB. For login, the user should exist in DB and the password should match. And for the third party user, if the user does not exist, store in the DB. If it already exists, just skip and call the authentication server. So this many part we have to implement it in the authentication. Each of these three flow. So here for this sign in and login flow, what needs to be authenticated is a username and password. But here there is nothing like that. So three flow have different parameters. So what we do is we will create a DTO and we will specify the parameters there. Here we will create a package like DTO, and we'll create Java classes authentication DTO. Here what all I need, so I need username and password, username and password for the login and sign in flow, and for the third party provider we need a parameter like provider. So maybe we can create the provider as an enum. So we'll create a package called constant, and we will define the enum inside. So new Java class, we'll set as enum, and we'll give the enum as provider only. So here we will give, as of now we will have Google as a provider, and also we will specify local also. This is for the user who is signing using the username and password, which is a local user. So now coming back to the DTO, so here we will add private provider, so to generate getters and setters I will give data on the lombok, and also I will enable a builder annotation also. So this will create a builder class also inside this. So using this builder it will be easy to set the values for this authentication DTO. So that's it for the authentication DTO. So again, coming back to the service authentication service which we created. Sorry, I created in the implementation. Sorry, I will just move back to the service layer. Yeah. So authentication. So the method we will use is authenticate, and the param is authentication DTO. Give us a request. So now what does this authentication service should return? This authentication service should return the same access token from the authorization application, but we will not use the same response class. Instead we will create another class which again contains the access token only. So we, after getting the authorization application response with the token in the here in this authorization token response record, we substitute that to a new class so that that class can be sent to the front end. So this response we can define here in the VO. We'll say another package inside VO as response, and here we'll create a new class authentication response. Authentication response, and this also we create as a record only. So record, and here also string access token. Fine. So this we will give us the response of this abstract method. Okay. So this interface contains one method which is authenticate, which expects authentication DTO as a request and send a response as authentication response. Now we have to implement this class. So we have different flows here, but if you see in each flow there are some database operations and the calling of this authorization. So calling is done using this authorization service. So to invoke this service, and some database operations are common. So now if we implement this authorization service for each flow, if we create one implementation, in each implementation we have to use some repetitive logic everywhere, which results in repetitive code. So instead of doing that, we can create an abstract class where we keep the common logic, and from that abstract class we can extend a class specific to these three flows. So let's create an abstract class. So here inside the implementation, Java class, and here we will create that abstract class. We can give us user authentication service. And we make this class as abstract, so this cannot be instantiated, only its child class can be instantiated. And this in turn implements authentication service, protected, because this should be accessed only from this class and the child class, not from anywhere. So we define as protected application response, and we give us authenticate. So we do final and inject this one, API client authorization service here. Yeah, so here we will annotate we should need a at all our constructor, okay, so that when this abstract class is instantiated using its child class, these final values will be substituted from there. So basically this has to be injected from the child classes. So now we need API client service dot generate token, and we need authorization params. So we create the authorization params here. And there we have a map. String param is equal to new hash map will give, okay, and in this header param dot put, we have to define all the parameters which in the previous video which we have seen in the postman while calling the token response for the param. So we have one is the user ID, so yeah, so this is the param. So we need username, user ID, user provider, and the authorities. So this will give the authorization response, which we need to convert to authentication. So we will give return new authentication response. Okay, so from the authorization response, we take the access token and set to the authentication response. So this is fine. Now the value for this thing. So this value from the user request, correct? So in the user request we have the username, and the user ID is created when we insert that into the database, and the user provider, yeah, it can be local or Google. So that also comes in that DTO. This DTO we have that provider, and authorities. So authorities we can set here. So this is for the user authentication only, so only the user role only we have to set. So we will define the authorities here. So to set the authorities, we may here we need an authority like user role. So instead of using as a string, we will define an enum for this as well. So in the constant, we will create a Java class enum and name the enum as role, and inside that we will give role user as the user role. So now coming back to the user authentication service, so we will give private final list of role and gives us user roles is equal to list dot now, and we will specify role dot user. So in future, if you want to add many roles, we can specify that role here in the enum, and then we can apply here, which is specific to user. So all will be placed in one place rather than segregating in different pieces of code. So now, as we seen in the previous video, the authorities has to be set as a comma separated value. So this list we will separate as a comma separated value. Now for other data, so we need user ID, username. So to generate that, the entry has to be made in the database. So we have to now define the database operation in our code. To define the database, first we have to create the table. So we'll bring the corresponding libraries here. So we'll add dependency. So we will add these three dependencies. So one is the data JPA, Java Persistence API, and next is the database library. So here this application we are running in an in-memory database, so we are using H2 database only. We are not defining any other database here. And then this Flyway DB. This Flyway DB is a database management tool. This will take care of deploying any SQL specified in our project to the database. So we don't want to do any manual deployment, or we don't need to write any other scripts or anything to deploy the SQL to the database. This Flyway DB will take care of it. So to do that, we have to create a folder under the resource folder, especially in a class path. Wherever the Java class path is there, we have to create a folder in the format db, and inside that again another folder as migration. Yeah, in this format, and then we have to create the file, which also has a naming pattern, which should start with version B for version and the version number, then 2 underscores, then a meaningful name. So this is the first SQL, I will name it as init database.sql. So now inside this, I will define the table which we need. So table is for storing the user detail. So this is the SQL for creating a table. So where we have defined the table name as user underscore detail. We have the column name as ID, which is the primary key, and it will be auto generated. And next column is the user ID, which is a randomly generated unique number. So this user ID will be, means each row will have each unique value. Then comes the username, which comes from the input and the provider, either it is local or Google, and the password. This password only comes for those users signing via username and password, not from the Google user. Google user doesn't have a password, so that's only doesn't create as not null. It is not mandatory. Then the created time for the audit purpose, just to monitor the table when it was created or when it was updated. And here if you see, as I mentioned, the user ID is kept as unique because each row it will create a unique user ID, and the username and provider combination is kept as unique because there can be, since we are getting the username from different third-party sources also, there can be a possibility that same username can come who register via the, from our UI side or from the third-party side. So to avoid that conflict, the username and provider is kept as unique, so that multiple rows with same username can exist, but username corresponding to a provider, there will be one. Means for the local, whoever is authenticating from our system will correspond to local provider. So for the local provider, that all the username will be unique. Same for the Google provider also, the username will be unique. So this is the table detail. Fine. Now we can create an entity class for this table. So come here, create a new package, name the package as entity, and inside that we can create an entity class, new Java class, and give the class name as user detail. This is same to that of the table name we created. Create the class and annotate with the annotation at entity. Yeah. User detail. Now, and we have to give all the, define the variable for all these column names. So we need ID, and okay, and we'll give generated value as identity because this should be a primary key and should be auto generated. The next field is user ID. Now here we don't want to annotate with that column annotation, because if we follow the camel case naming for the variable for what the column name in the table, then we don't need to annotate with column, because if you see user ID, user underscore ID, and we have followed the camel case where user starts with small letter and ID starts with the capital letter. So we have given all the column names. So here provider is the enum. So when we are giving enum, we have to annotate with the enumerated, and we should give enum type as string. By default, the enum type is an ordinal value. So the ordinal value is nothing. It will give a number to the enum defined here. So local will be corresponding to number 1, Google will be number 2. So if we give ordinal, or if we didn't give anything, default take ordinal, and it will assign an integer value in the column. In the table column, it will store this as an integer value. This will be a problem. For example, now when we are using this order, okay, we can identify local as 1 and Google 2. But tomorrow, if someone introduced a enum in between these things, local and Google, we introduce something, then the ordinal changes here. But the same will be not changed in the table, which will cause a conflict. So that's only we are going with the enum type string. So it will store the string value like local or Google, like that. Now we will give the getters and setters. Fine. So the entity is ready. Now we have to create a repository. So we'll create a package here. New package, repository, and we will create the class for it, which will give which should be an interface, user detail repository, and this interface should extend JPA repository, and param types are, one is the entity name, which is user detail, and another is the primary key ID. ID is a long, ID is nothing, this column long ID, so we have to give the long type there. So the repository is also now ready. Now coming back to the service layer, where we finished writing this user authentication service in abstract class. Now we have to extend this class for our for our flow. These are the flow. So we have the first sign-in flow. So now let's start with the sign-in flow. So this user authentication service, we can create a child class as sign-in user authentication service. So we will come here, Java class, we keep sign-in user authentication service. And this class should now extend user authentication service. So it will ask to implement the authentication service method, and also we have to create a constructor which should match the parent class constructor. So parent class, if you see, we are expecting a constructor with the API client authorization service. So we created that class. So this will be auto-wired by the Spring. This is a constructor based auto-wiring, so it will constructor based dependency injection. So this object will be injected here. Flow again. So what in the sign-in flow, what we need? So we will get requests, that the DTO request, and that. So first we need to check whether the user exists in the database or not. So for that, now we will auto-wire the user detail repository, which we just created. Fine. So how will we check? We should check based on the username as well as the provider. Correct. So if you go to the user detail repository, we don't have a method. We can use a JPA method like find by ID, but here find by ID, we don't have the ID first of all. So we have to use the custom columns. So we have to do the other date columns, so which are username and the provider, because that is a unique combination. So we get the username from the request, and we know the sign-in is called only for the local user. So we come here to the repository and create a method. Method name we can give, we will give us find by the field name, find by user name, and what is other field? Provider. So name and provider. So username is a string username, and provider is the enum. And what we return is, we will return an optional of user detail. Okay, so that's enough. Now we come to the service sign-in user authentication service. So here first we will check user detail repository dot find by username and provider, and in the request we have request.get username and request.get provider. Okay, so what is the next condition? If it exists, we should throw an exception, and we should send an error message back. So we'll put an optional here. User detail detail optional is this. So we'll just put a condition if user detail optional dot present. If it is present, then we should throw an exception. So we will create an exception. So again, we will package all the exception on package. So we create a package as exception, and here what user, we can give the exception name as user already exists. Exception. Okay. And this should extend runtime exception. Fine. So now we will come here, we will do new user already exists exception. We'll do that from here. Okay, we should throw new user already exists exception. Fine. And now we have to handle this exception so that it should give a message back. So for that, in the response, we should create a new class called error response. We will go with the record only. So record, and here we will give an error message. And now we have to, in the exception, we have to create an exception handler, which can be done using a controller advice. So we'll create exception handler. It should be a class, and we should annotate it with the @controller advice. Now we will handle the exception. So public response entity, and this responsibility will give the error response. And here we will write the method class handle exception, and here we will give @exception handler what is it, user already exception class. Okay, so here, so maybe we will rewrite this to application exception handler, so it will not conflict. And here we will just give exception handler. Okay, so that's fine. So that means whenever a user already exists exception is thrown from the project anywhere, from any code, it will be handled here and send us response accordingly from here. So if you have to give the user already exists exceptions, the parameter here, so exception, and now we should give return new response entity, and here the object is new error response, new error response, and HTTP status is conflict, new error response, and here we can send the exception message here, user already exists. What is this one? Okay, this is, okay, we imported a wrong class for the error response. So we will delete this and import the class which is this one, record, yeah, user already exists. That is what we need, right? User already exists. So this exception will be thrown back. Okay, now coming back to else. Else what is what? We should store the user detail into the database. So if you see, store the user detail will be used in this flow as well as here also we are using. So this can be then, the storage part can then be defined in our abstraction class so that it can, we don't want to write the repetitive code both in sign in user authentication service and also the service which are going to introduce here. So we will create something like protected user detail or save user detail. So what we get is we also get the input parameter as input parameter will be authentication DTO, because authentication DTO is what's still there in the service layer as of now. We haven't created the user detail. That's only we are creating this method to create the user detail. So let's give the name as authentication details. Now what we have to do is we again need we will create the user detail class here. So user detail user detail dot set username password set provider user ID then what all field we need. So user ID, username, provider, password, then created time and created by. Okay. So we will give DTO dot get username, DTO dot get password, DTO dot get provider, DTO dot get so user ID is something which we should uniquely create for each user. So here it is new date and created by, we will give us the same DTO dot get username. So we create a method to generate a random ID using UUID. So this will create a random string, and this string there is no possible combination, there is no possibility that it can create duplicate. According to the permutation and combination, out of 13 billion records only one can get duplicated. So anyway, 13 billion records is a very big number. To make it more bulletproof, I am adding the current instance time also. So with that, even in the 13 billion case also, if a duplicate comes, this will change that duplicity. So with this logic, we can make sure this unique ID we generated will be always unique. So that's fine. Now we have to save this and return back the user detail. So to save that, we need the user repository final. Either we can save in our service layer itself, or we can save it here. So if you want to save it here, we have to pass this. Maybe we will just map only and give back here. So maybe we can change the method name to map user detail. So to just map the user detail and send back. So return user detail. So that's perfect here. Now we will come again back to this thing. So if it is there, we will call map user detail and give the DTO request. So this what it will generate is an user detail class. Now another thing is the password present in this authentication DTO is not yet encrypted. This is what we receive from the front end. So we have to encrypt that password. We will create bean for password encoder. So we have to create a bean here. That's bean public password encoder. There will be a method as password encoder and return new. We will use the bcrypt encryption to encode the password. So we will create a bcrypt password encoder. Okay, now we can annotate this in our authentication service. So provide private. Okay, so what we do is, after mapping the user detail, we have the password already there, but we will set it back again here. So user detail dot password encoder dot encode, or the DTO dot get, sorry, request dot get password. Okay, so maybe then we can remove this password setting from here, so that we always make sure in the user detail only the encrypted password will be set. Fine, then we can save this. Save this user detail. And once we save, we will get the user, sorry, it will generate the ID in this entity object. So we will reassign that saved entity to the existing user detail object. So now coming back, so we have stored it. Now we have to call the authorization. So this thing already we have implemented. So the interfaces, and yeah, you don't need the interface, and we have implemented the logic here only. So we just need to call the authenticate. So return authenticate. And coming back here, we have defined the header params, but the values are not set. So now these values, whatever we need, will be present in the user detail. So what we can do is, we will go here and we substitute this object here, and from that object we can take all the values. What are the user detail dot get username, user detail dot get user ID, which is the UID generated string value which we have seen earlier, and dot get provider. Yeah, it should be string, so we change to string. Fine, so all the parameters required to pass to the authorization application is also set here, and this will call here. So now we will come back and pass this user detail here. So this will call the authentication, authenticate. What's the problem here? Yeah, so here, why? Because we have defined user detail inside here, so we will just bring this outside, or we can just use here only, because if this condition is always throwing, so there is no way the code will reach here. Either the code will stop here or stop here. So if it comes the else logic, we are returning, or we are throwing the exception. So here you can see this will set the params required to call the authorization application service, and here we are calling the authorization application using the REST template, and this will return a authorization access token object that is converted to the authentication response and sent back here, and this service layer now has to be called in the controller layer. So this much part is also, so now we have implemented this part, we have already implemented this part, so now we have integrated these two things. Now we are here, so we have to implement the sign-in controller part. So to sign controller, we have to create another package. Controller. And annotate with REST controller. We'll annotate with the request mapping also. So that is the URL path. So we will keep this as user auth sign in. Maybe we can define this as the service endpoint. So we can define this user auth instead of constant. We will create a new constant as controller constant. We give us public static final string endpoint and defines this one user auth. So this is the endpoint. Now we can use that here because other controllers also we use the same endpoint. Okay, so that's fine. So request mapping is done. Now we have to create the request method. So public response entity. We'll name the method as sign in, and we need the request body. So request body now we have to define. So we'll come to the view class here. We'll create a package again, new package. We'll give the package name as request, and here the request what comes for sign in, username and password. So we'll give new class and create as a record only that also, and we will give us authentication request. Authentication request, and this authentication request will contain a string username and a string password. Fine, that is enough. We will go back here and the request body will map it as authentication request and give it as request. Then we have to call the service layer service which we created, is sign in authentication service. So we'll auto wire that at auto wire private sign in authentication service, and we'll give it as. And before that, let me go and check. Did I annotate it? No, I haven't annotated. Otherwise, Spring will not understand it as a bean. So we have to annotate here. So the Spring will understand it as a bean and create an object for it and inject it where the dependency is used. Okay. So response entity. Response entity. What is the response? We already created the response. It is the authentication response, right? We already created authentication response. Authentication response. Fine. Now we will call this signing. So we have already implemented the logic. All this logic is there. We just need to call that only. So which is authenticate. And what we need is a DTO. So we have to convert this to the DTO. So to convert it, we have, if you remember when I defined this class, I given a builder annotation here so that it will be easy to create this thing using the builder method. So authentication.builder, and what all we need? We need to set username, builder username, so that will be the request dot username, and then what? We will give one by one line, so it will be easy to understand the code. The username, then the password. So password is also request dot password, and you see we need username, password. Yeah, this flag was not okay. Initially I thought like we will create one controller and use for both sign and login, but we will as I progressed, I thought like we'll create independent controllers. So this flag is required if we are using the logic in the same class. That is again break the design patterns. Single responsibility design pattern. Single responsibility say that one class is for one logic only, one responsibility only. So I don't want that. So only these three things enough. So request username and request password. and then what, dot build. So it will build this thing and okay, authenticate, but now we need a response entity. So response entity will create return new response entity. So response entity body, response body will be having the authentication response which we get from this method, and to give the http status dot okay. Fine. So with that we finished the sign in part, this part completely. So on clicking sign in button, the request will hit this endpoint, sign in endpoint, and this from this sign in controller we call the service layer to authenticate. So this is entry point authenticate. So authenticate, inside that first it will check the user exists or not, that logic is here. Then if everything is fine, we will store the data, and then the call the authorization application. Your authorization application is called here to generate the token with the params required here, and this will call the authorization application as defined here in this variables, and call that and get the response back. So that's pretty much with the sign-in controller. Now we will go for the login service. So login also we have to create a service like this. So we'll come to the service layer, we'll create the Java classes login user. That's it, right? Because we are implementing the user authentication service. Which extends user authentication service. Then okay, we'll give the implement method authenticate, and we will create a constructor. Okay, and yeah, so definitely we need to inject with the service layer. Is there login? We just need to check if it exists, then well and good. If it does not exist, we should throw an error message. Okay, so annotate with the user detail repository at auto-wire private user detail repository. Okay, so first logic is user find by username and provider. So we'll see request dot get username. Yeah, we need to set the provider. Yeah, this I missed here in the sign-in controller. When I create authentication DTO, I give a username and password, but we need the provider also, because provider is used to fetch the DB. So here provider, and the provider will be provider.local. Yeah, because this is called only for the local provider, so we can hard code here. Just when I'm developing this login user service, and when I call this method, it strike me. So request dot get provider. So find by username, it will give an optional. So how we handle that if it does not exist? So we can use or else throw method here. This how it will do is it will find the optional. If the option does not exist, it should throw. That is what, if it does not exist, throw the exception. And this exception is now is user does not exist exception. So we have our user already existed. Now we will create another exception, user not found exception. And the message should be user does not exist. User not found exception, and it should extend runtime exception. Fine. And now we come here and we will throw or else what, user not found exception, and we give the constructor reference. So it will in turn throw the exception here, and if it's find, it will give the user detail. Okay, so in one line we can throw the exception. Also, if it is find, we can get that. So this much thing we can write in one line. Now this exception has to be handled in the controller advice, otherwise we will not get the exception back. So that is here. So just copy paste this one, and here now the handling is user not found exception, and here also it should be user not found exception, and the message is user does not exist. User does not exist. User does not exist. And this should not be conflict, this should be not found. HTTP code not found. Here it is conflict because the user already exists, so it created a conflict. Here the user does not even exist, so it's not found. Fine. Now coming to login user service, we found out, and then what's in this logic? If it is find, verify the password. Yeah, okay. So now we need the password encryptor here also, private password encoder. Okay, so we got the user detail and we have the password there. So password encoder dot matches. So raw password is request dot get. It's a raw password, and encoded already encoded password is in the database, not get password. Correct? It is showing matches raw password and the encode password. Raw password is input password and encode is already existing DB. That's what here, right? Verify the password matching or not matching. So if it does not match, if the raw password does not match, what? Then again we have to give an exception invalid. So that we can create as an authentication exception in Java class. Authentication exception. Authentication exception. Oh, sorry. Wrongly clicked on interface. Okay, authentication exception, and this will extend again the runtime exception. And now we have to handle that also. We'll come here. Authentication exception. And here in authentication exception we should give invalid credential. So the message should be invalid credentials, and maintain the cases in the messages accordingly. Okay, and here it will be unauthorized, correct, because he has entered a wrong password, that's why it's not matching. So coming here, if it does not, then we will throw an exception, new authentication exception. We should throw it. Okay. No, if it is matching, then it will come outside this if loop. Then what we have to call again, that we have to call the logic already implemented here. So authenticate, what we have to give the user detail, correct? So here we don't want to save anything, we just need to call it. So it comes here, authenticate, it just called. This mapping and saving is not required. Fine, so that's about login. So now we'll create a login controller. Where is the controller here? Yeah, so new Java class login controller. Again, this will be a REST controller and request mapping. So again, we don't need this, we'll use the endpoint. And here it will give us endpoint login, right? This one is endpoint signing, endpoint login. So same way we have to create this one, and we'll copy this. So here instead of sign in authentication, login user authentication, and here also you can change the method to login, and we'll use login user authentication service authenticate. Again, username, password, and the provide REST locker. So it will come here, it will check if the user already exists. If it does not exist, throw the exception. If it exists, check the password. If it is matching, if it is not matching, throw authentication exception. If it is matching, authenticate and call the authorization application and get the token back. Right. So we have finished this login flow also. Now we will come with this third-party OAuth provider. So third-party OAuth provider, this verification of this token is done by the Springboot security only. So before doing that code, we can implement the service layer. So here also we need to check the existing user exists in the database or not. If it exists, don't do anything, just call the authorization application. If it does not exist, store that in the database. So that logic we will create in the service layer. So here now again coming, we will create a service layer for that third party. So we'll name as third party authentication, user authentication service. Class, and this also extends which are user authentication service. Okay, third party has a naming issue also. Refactor, rename, and D got missed while typing. Okay, user authentication service. Now we implement that method and create the constructor also, which matches the super class, which is user authentication service. Fine, and now what's the logic? We have to check whether the data user exists or not. If exists, save it, and does not exist. Okay, so it will be, we can use almost same logic of here. Party, so we auto-wire the user repository. Now what I have to do is sign in. This logic I have to take, but the only thing is I don't want to throw an exception here. So only thing I have to change the logic is if it is not present and no password also, we don't need password here. User, this third party will not have password. We map the user details. So map the user details, the username, provider, and the unique ID. So we call that. If it does not present, save there. So it will be something like user detail, and this method has to be called everywhere. Okay, but we need the user detail here. So what we can do is we can change it. We will change this. What we can do is we will delete this here, and we can say find username, or else not throwing, or else if it does not find, what we have to do, we have to save that. We should call this or else save, and save user detail is what we will map from here. Okay, or else save this. So we will get user detail as here and return this one. Look, we written in one line. So first it will check the user exists in the database. If exists, if not exists, throw the data. So if not exists, that is or else. If not exists, it will save the database. If it exists, give that to the user detail. If not exists, it save and give saved on to the user detail object. And then finally we call the authorization application, that is via user authentication. With service, let's see, login also is annotated, all the services are annotated. Fine. Now coming to the controller side, that is this one, this controller. So we will name as new Java class third party sign in controller. and same way we have to annotate here. Endpoints we will give third parties, which is will give us 3P and sign, third party sign. Almost the same logic. Here it will be the third party authentication service. It's authentication service, and here we will not the authentication request in this case will differ. So we will give the request as third party authentication request. Authentication request. Again, it is again a record, and here we will have only provider. Yeah, we'll get only the provider. Okay, and now we will inject that here in the third party sign control. So request import class. So it will not contain username and password. It will contain only the provider, and this provider is what we receive from there, because this control will be used for multiple third party. Now we have only Google, but in future it can be Facebook or anything can come into picture, so that we cannot hard code. Whatever received from the request, that we have to set here. So request dot provider and build, and this will call the authentication. Check the user exists. If does not exist, save it. If exists, check that user detail and authenticate that. So we have finished till here. Now the Springboot security to validate the token. So for that we have to create a config class. So we'll create a package first. New package config. Here we will create new Java class security config. Here we will annotate that with configuration and enable web security. So here we need to create a security filter chain bean and add security library so that this token can be verified. So to do that, first we will add the bean for the security filter chain here, which will have an input parameter like HTTP security. So we will return HTTP security dot build. So this will give a security filter chain, and now we have to add the filter parameters, filter options. Add dot authorize HTTP request. So this is expecting a HTTP request customizer request. So or dot any request dot authenticated. So this means that any request coming to this web this application, this web application, only after authentication only it will be the further controller will be called. If there is no authentication, it restricts that, and no controller can be called without the authentication. So that is the first thing we will add. Now next we have to call the OAuth2 resource server. So we get the OAuth here, and OAuth2 dot what we have to call is an authentication manager resolver. So now we have to create a bean for this authentication manager resolver. So this is the bean for So this is the bean for we can provide it as public. So this is the bean for the authentication manager. So this we can call it here. Okay, so now we have to define the bean. So authentication manager resolver, we will define the authentication managers for the corresponding authentication issue. Here Google is our authentication issuer, so we have to verify the token for the Google. Coming to here, so we have to create a map of string and authentication manager, and just give us map only, a new hash map we will give here. Fine. Now inside this map we have to put the issuer. So the key will be the string. The key will be a string which is nothing the OAuth issuer. So for Google, the OAuth issuer URL is this one, http://accounts.google.com. And now we have to create an authentication manager. So the authentication manager, again we will create another method. Okay, it's like this. Authentication manager, it expects a JWK. We need the JWK to validate this token. So JWK should be fetched from the third party auth provider, so that for fetching the JWK we need an URL. So that is what given in the authentication manager. We set the JWK URI and return back. So here when it comes, we have to call that authentication manager and set the JWK URI. Start. And for the Google, the JWK URI, you can see it here in this URL. So this is the issuer URL and this is the JWK URL. So Springboot intent will use this JWK URL to fetch the keys and then validate the token. So now we have put in the hash map. Now we have to create a JWK authentication manager resolver. So for that, return new JWK issuer authentication manager resolver. Now if you come here to the authentication manager resolver, so if you go here, this is again a kind of functional interface which have one abstract method resolve and expecting a generic C. So generic C is nothing, a string. So what does it expect is this functional method expect a string and it will return an authentication manager. So in our class also we have in the hash map authentication manager as the value and this as the key. So we can use that functional reference here. So that hash map method reference to replace or to substitute for the, what was that, this one, authentication manager resolver interface. So what we can do is map get. Okay, so what map get means, we are giving the method reference here. So when this authentication manager resolve is called by the Spring framework, it will call the resolve method. Resolve method input is string and expected is an authentication manager. So here also this map.get method also behaves same way. Expected is string and output is an authentication manager. So this way, when the Springboot get a token, from the token it will get the issuer URL. So for that issuer URL, it will go to this manager resolver and use this issuer to find the corresponding key that we have stored here. So this key will be returned back to the Spring framework. So once the Springboot framework, security framework receives this JWK URL, it will call this URL to get the keys. So I can show you how the keys will look. If I call this in the browser, you can see these are the keys. So these keys Springboot will get. Using these keys, it can validate the token and verify if the token is valid or not. verification part is over. Authorize HTTP any request authenticated. Now we will set some other parameters which we required here. HTTP security, session management. Never, because we never maintain a session. So the session will create an issue, but will never create, but if use. So that means never is also not okay. Stateless. So stateless means will never create and it will never use obtain security control. So we need a stateless session. Now another thing we need is the course. This is because this application, so you can see here, it will be called from the web page. So web page we have to enable the course, otherwise from the web page we cannot call it. So http security dot course. So for the course we need c dot configuration, course configuration source. So we have to create another bean. Yeah, so this is the course configuration source bean. So here what we are doing is it should allow all methods like get, put, post, delete, and allow headers. That means in the input request any headers the front end can send, and allowed version any can be. For time being, this is since we are used for testing purpose, we give allowed version anything. But in a production environment, we can restrict it from which front end URL only it is allowed. We can define that URL here so that it will allow only from those web pages. And expose headerless means in the response back it will say, because always when the browser call, it will first call a pre-flight API. So in that API, only if this access control allow origin is sent as response, the browser will allow to call the actual API. So that's why we are setting this as a response back. If this is not set, the browser from where the front end is calling, the browser will restrict to call the corresponding backend API. And URL pattern, any URL. This /star means any URL can be in this backend service can be called from the front end. So now we will give this course configuration as well here. So this is a configuration which will, so basically this one, these two will take care of restricting any request and verifying the token. So now one problem arises, these two flow, the login flow and sign in flow does not have any access token, and it is not an authenticated flow. So because of this condition here, the same security will try to apply for the login, which we never required. For the login and sign-in flow itself is an authentication flow which is done inside our service layer. So we don't want the Spring security to do a further authentication and restrict that flow. So what we do is we need to skip that two flows from the security filter. So for that we will add another configuration here. For web security customizer, there what we do is any request matching this endpoint sign-in. So if you see the sign-in controller, endpoint sign-in and login controller, endpoint login, sign-in and login, sign-in, yeah. For this, the security should be ignored. So this configuration makes sure that for these two URL, the security should be ignored, and for remaining everything, as of now we have the remaining URL is for third-party sign-in URL, this one 3P sign. So this third-party sign-in URL, when it tries to hit our controller here, before that the Spring security will act and validate the token, and if during the validation, if it finds there is any issue in the token, it will not even allow to call the controller, and it will just send a response back. So maybe so that's the configuration for the Springboot OAuth2 resource server, Springboot OAuth2 resource server. And now we have done almost. Now something which we missed is in the application we didn't specify the database details and details. So we will add that. So we are, as I told earlier, we are using the in-memory database. So we will add the configuration here. So we are defining the data source URL. This is H2 memory database. The database name is localDB, and H2 console we are enabling so that we can see the entries are made. Yeah, if we enable the console, this console will be also restricted by the security config. So we have to ignore that URL also. So it's like H2 hyphen console star means H2 console, and any request coming after this endpoint also it should not, I mean security should not act there, it should ignore there. Okay, so that's about the H2 console. And JPA Hibernate DDL auto is validate only. We don't want to update or create anything from the entity layer. We just validate whether the entity is correct or not only. If you give us create here, whatever entity is there, it will try to create the database. That is not required because we are using Flyway and we are using SQL script to create the database tables. So this we just validate. And dialect, the Hibernate dialect we are using Postgre only because a dialect is important. H2 memory database itself doesn't have a dialect. We have to use a dialect. So we are going with PostgreSQL dialect because in future if you want to deploy this in a standalone database, we thought of using Postgre database only. So we are using that dialect here. And format SQL is to, this is when we see in the logs the SQL will be formatted. And one more thing we can add here, debug as true, so that we can see the logs, debug logs in our console. And this is already there for calling the OAuth, means authorization application, that thing. And one more thing we have to add here is at enable transaction management. This is because in the sign-in and third-party user authentication service, we are creating inserting data into the database, so and then calling the authorization update. So in case of any error, if you are not using transaction management, data will become inconsistent. So to avoid that, what we do is this thing we would annotate with the transaction address, so that for example here if you take this case, the data is inserted and while calling the authentication due to some error we didn't get the token. So in that case, if the transaction is not there, the data will be stored in the DB, but the user will not get the access token and thereby he will not be authenticated. That is an inconsistent. If the access token is not generated, then the user should not be also saved here. So with using the transactional management, if there is any exception happening in authentication, the saved data from the table will be also rolled back. So same will be applicable for third-party authentications. Here also we have save and then authenticate. So index transaction. So enabling transaction only in the main class we have given the enable transaction management. So let's cross check all again and see everything is fine. Request body, login, again third party sign in, and the security config. Now let's try to build this and see if there is any error or everything is fine or not. Edit configuration, Maven. So here clean package. Okay, build is successful. Yeah, target code is generated and we should see the jar here is user authentication service.jar. Now let's try to run the application. Springboot run, apply. Okay, let's run and see if it is starting or any exception. Okay, application has started correctly. Now let's test this each flow, login flow and sign in flow using the Postman. So the Postman is here, so I have already created the requests for the user authentication service in this Postman. So let's test the sign in flow. So here I am giving the request as username, code with Anish, password 123456, and if you see authorization, nothing is there. Let's see if it is working or not. But to make it work, what we need is our authorization application should also should be running. So let's open that as well. So here is the authorization application. I will run that as well. Okay, so that is also started. Now let's see, we'll send the request and see anything coming. Yeah, it's showing some error. So I find some issues in the code due to which it was not working properly. So first one is here, if you see, I have given I here, so it should be signing. And if you give endpoint, I have given a slash at the end and also defined a slash here. So two slashes not going good, so it should contain slash only, starting slash only here. So I have to remove the end slash from this. And next thing is, yeah, all the methods should be mapped with appropriate mapping. So these are our post requests, so we have to map with post mapping. So I haven't done that post mapping here. So login controller here also I should do that post mapping, and sign in controller third party. So that's here, and remaining all typos here, everything looks good. And now in the exception handling, so we have handled for the exception, the predefined exceptions like user not found. Now for any other exception also we should handle it so that we get a meaningful message in the front end. So here I will give exception plus generic, any exception it should be handled here, and here it should be some internal error, internal server error, and error message like we can give oops, something went wrong. Okay, so that in the front end we can understand that something, because if you didn't handle that, some other unmeaningful message will come. It will be confusing for the front end. So better we'll handle the exceptions here. Okay, so with these changes, let's start again and see if it is working or not. It has started. Now we'll test in the Postman. Now let's try it and see if it is working or not. So we'll send it here. Okay, so that means it has worked. So the flow has successfully sent from the instead of front end Postman. It sent to sign-in controller. It checked all this logic, called the authorization, and returned the access token. So we got the access token, and we can check this access token as well, if it is valid or not. Okay, we'll paste the token here, and if you can see, we have the details, but something is missing. We don't have the authorities, we don't have the username. So that means while calling that, it has not set that values properly. So yeah, so what we did the mistake is, this is what the param name which we required in the token, and the header param name is usernames in the uppercase. Yes, that's the mistake we did. Okay, we will avoid this and we'll change accordingly. So that's the reason it was not handling. So here what we have to give is, we have to give the name as, yeah, it was a coding issue. The header name is in the uppercase, not with the hyphen. The hyphen that will come in the access token only. So user ID, user provider, and user role. Fine. Let's start it again and see if it is working fine. Okay, fine. Now let's try to call once again. Yeah, we got the token now. Here and decode it. Yes, fine. You got the username as code with Anish. That's what we have sent here. And authority sole user, which we are setting from the user authentication service. Provider is local, because this is a local user, not from a third-party user. And issuer, when I was explaining the code for the Google Auth provider, I told the issuer. So same way, the token from the Google will also contain the issuer with the account.google.com. Here it is from our authorization application, which is running in the localhost 80. So this is the issuer, and the user ID. Look, this is a random job. Now we can check the H2 console also. Okay, connect here. So this is the H2 console, and we come and check for the detail. Yeah, so the detail which signed in now. The user ID randomly generated, unique ID, and the code with Anish, provide log, and the password you can see, right? This is we send us 12346. It got encrypted and stored in the encrypted format, and the created time and the created value. So perfect. That means sign in working. Now we want to check the login. So login also, it will also the same parameters like code with Anish, and now this 12456. Now if we send it here, perfect, the token has come, and we can cross check. This token should be also, yep, the same token has come here as well, and the user ID is the same user ID 39A14 ending with 1854. Yes, same user ID is fetched. And now coming back, we will test negative testing. Will change the password here with the 7 and C, and we expect an error message here. Perfect, error message invalid credentials. That is this flow. Sorry, this flow. And we can test this flow if user does not exist. So we will give code with Anish 1 and test it. User does not exist. So these two negative flows are tested. Same way in the sign-in controller, we'll try to create this once again. So we should say user already exists here. So this flow. So we have tested this flow, and we have tested this flow, and we have tested this one and this one and this one also for login. Now coming to the OAuth, third-party OAuth provider user. So here we have a request, and we need a token. So this token, this third-party token, now as of now, we don't have a direct approach to get it. So I use some different approach to create to get two tokens from Google. So first we will take the positive flow with a valid token. So this is a Google token I have managed to got. So now we will try to send this and see if the token is generated. So when I send it, something went wrong here. Okay, so what? It's not able to get the username. Okay. So what we need, yes, you hear what went wrong is like the third-party sign-in controller. For the authentication purpose, we need the username, but the third-party authentication request only send the provider in the input request. The username we will not send here. This is because username should be received from this token only. So we have to set the username here. Dot username, we have to set it here. So we have the authentication. From that authentication, we have to get the claim, and from that claim for Google, we are selecting the email. Token is mapped to an authentication by the Springboot framework during the security check. So we will inject that here, and from here we will get, we'll call this method get username, auth, and the provider we get from the provider. Okay, so with that we will derive the username for Google. Time being we are using only Google, so we have put a condition. In future, if we want other provider, we can add another condition. Fine, so let's restart it again and check. Okay, authorization, the body only the provider. Now let's check. Okay, so now here if you can see the flow here, look, during the security authentication, the Springboot security calls the JWK for the Google. This is the JWK, which while doing the coding itself, I have showed you. Look, this is what we have given here. Google APIs COM OAuth2 v3 certificate. And I have showed the keys also. So when the Springboot called this URL, it will get the JSON web keys. With that web keys, it will validate, and once the validation is successful only, it will call the corresponding controller. If the validation goes wrong, it will not call that. We can see the H2 console once again. So this H2 console is an in-memory database. So whenever we restart the system, the old data will be lost. So now you cannot see the previous data, only the new data will be there. Yeah, you see the username which we got from the token, and the provider is Google. Password is not there because this is a third-party authenticated user, and a unique user ID is created. And the token we received, now if we decode it, we should see all the details. Yeah, you can see code with Anish, that user ID, the provider is Google, and the authority is stored user. So perfect. Now I will test with an invalid token as well as an expired token. Let's try to call this. So look, so we got an 401 on unauthorized error, and the error detail is given here. So you can see here invalid issuer. So when we given an invalid token, it will not even go to the flow, it will get an unauthorized error. Same way, we will now test with an expired token from Google. Now if we try it, this also resulted in unauthorized, and if you see the error here, it will say an error occurred. Why? Because the JWT token expired. So it is already expired, and error is invalid token. So we managed to test all this flow. The invalid token, we got an invalid token message. For a valid token it went, and if the user existed, it created it. If it does not exist, okay, maybe we can check that flow as well. So now if you see, the user already exists. Now for the same user, if we try to authenticate again, we should not get an entry here, but we should get an access token from the authorization application. So we will give an valid token and send it here. Okay, so here what there is, it is trying to insert it again. Some logic is wrong here in our third-party signing controller. Authenticate, find by username, request.get username, request.get provider. Okay, there was a small issue here. Here it should not be or else, it should be or else get, and here it should be supplier. So we should return after what we save it. So due to this only the issue is coming. So we will stop this and run it again and see if this is working fine. It again. Okay, we'll first try to send new token, and let's see if the user is created there. Here again it will be, every time we start and stop, the memory data get deleted. So cut it again. So now if you see, it should contain this thing. Now if again I try with the same token, it should go through without creating the new entry and without any error and get the access token. Yeah, it successfully came here and we got the token. So this token, if we check there, it just came with the same user ID and the same username and user ID 6606. Okay, so that's all. We have tested all the scenarios for this 3 flows. So with this, we coming back to our architecture, we finished this thing completely. So in the first video we finished this authorization application. Now in this video we finished the user authentication service, and we tested the flow also, the sign-in request, the login request, and the Google sign-in request. So everything was successful, and I was finally able to create an access token for all the 3 cases. Now what we have to do is, we will create a microservice, a sample microservice, to test with this token we generated, and to make sure this microservice accepts this token and verify it and authenticates only those users with the valid token. So we will see that in the next video. Thank you.